All right, good afternoon. Welcome everybody to the UCSF-Stanford CERCI FDA Distinguished Speaker Series on Cybersecurity for Biomedical Engineering. My name is Kevin Fu, and I am the seminar series moderator and coordinator. A couple disclaimers before we get into our talk today by Michelle Jump, CEO of MedSec. This seminar series does not represent the official FDA policy or guidance. The contents are those of the speakers and do not necessarily represent the official views of, nor an endorsement by FDA, HHS, or the US government. This seminar is being recorded. I am your moderator today. I'll be joining the faculty of Northeastern University in Electrical Computer Engineering and the Curry College of Computer Sciences next month. You can connect with me down below, Dr. Kevin Fu on LinkedIn, if you'd like to communicate after the session. So before we get to our speaker today, I want to just again level set for those of you who might be new to the seminar series. There's been a long history of cybersecurity threats against the healthcare sector. One of the newspaper articles from earlier this year in the Wall Street Journal pointed out how a hacking group was planning to attack more than 400 US hospitals, trying to cause panic. And so what we've seen over the last 10 and 20 years is a shift from theoretical threats to actual nation state level threats. And we can no longer simply ignore the theoretical cybersecurity risks faced by the healthcare community and the medical device manufacturing enterprise. So why is cybersecurity so important for biomedical engineering? Well, you have to build in cybersecurity. It's very difficult to bolt it on after the fact. And so we're seeing quite a bit of effort in the United States with different kinds of legislative approaches, as well as executive orders to improve cybersecurity through regulatory means, through purchasing mechanisms, and other engineering approaches. I think most people on this call are already well aware of the draft guidance from the Food and Drug Administration in the United States. It's called Cybersecurity in Medical Devices, Quality System Considerations and Content of Pre-Market Submissions, Draft Guidance, or what many of us in the industry like to call the draft pre-market recommendations for medical device security. What would be expected and recommended to be built into medical device design to counter the endemic cybersecurity threats? That guidance document, which is in draft stage, is a nice springboard to introduce our speaker for today, Michelle Jump, who is an expert in regulatory affairs for medical device security. She is the CEO of MedSec, and she is responsible for the strategic leadership. But where I know Michelle most is through training and education, because we've been working together for, I want to say, more than a decade, I think, through several of her previous roles in medical device security, especially in work on development of standards, which are now FDA recognized consensus standards, such as the AAMI TIR 57, which was the very first document recognized by the Food and Drug Administration for improving the pre-market approach to medical device security for the design of medical devices. And there are now many more guidance documents and standards documents that Michelle is involved with. And so without any further ado, again, I'd like to hand over the virtual podium to Michelle. Thank you so much for taking time to close out our year, our 2022 speaker series. And I hope you leave us with a happy holiday note about regulatory affairs and medical device security.
Thanks, Kevin. I appreciate it. Thanks, everyone, for joining, and thank you for the warm welcome and invitation to this talk. Kevin, I've always enjoyed working with you on all of the things that we've worked in the past, and this is just one more of those areas. So as Kevin mentioned, we're going to talk a little bit about regulatory affairs today. And I talk a lot about regulatory affairs for medical device security. My background is in the standards and regulatory space, which is a little bit unusual. A lot of folks in the security realm are more on the technical side. I've spent the last 12 years focusing on how regulators and how strategically to approach cybersecurity, software based issues and interoperability for submission approaches and for compliance. So I've worked in that space for a long time. Standards drive understanding of how to implement those regulatory expectations. And so I work on both sides of those areas. I do have a master's in both regulatory science and a master's in biotechnology, and have been focused in this space, as I said, for about 12 years. I speak about these issues a lot, and I teach a 2-day course actually on regulatory issues around cybersecurity. It's a very big space, and we could talk for quite some time. But the way I approach this particular presentation is I'd like to talk to you guys a little bit about why regulators are focusing so heavily. Kevin did a very nice overview of some of those drivers. We're going to talk a little bit more about why are regulators so keenly focused on addressing security, and what are they focused on? Fortunately for us, there's a lot of commonality across all the various regulatory agencies and what they're expecting. So I'm going to talk to you more in buckets of what you need to think about when you're considering what regulators are going to want to see as evidence as part of the management of security for medical devices. And we're going to talk a little bit about some challenges for addressing this as we go through. But I wanted to start a little bit about reminding everyone that a big reason that hospitals have come under scrutiny and the security of those hospitals is because hospitals are considered part of the critical infrastructure of the nation. And so, meaning that if they were incapacitated or destroyed, there'd be a debilitating impact on our physical or economic security or public health and safety. We saw huge impacts during COVID when the seams of our very healthcare infrastructure was being pressed on a daily basis, and the security issues were actually elevated and increased during that time as well. So Kevin showed the most recent guidance from FDA, draft released in April. That's not the first, nor will it probably be the last guidance that came out of FDA. The first one came out and final was the pre-market guidance, the original one in 2014. So this is not something new to our industry, but as you can see by this slide, we still have issues. 53% of connected vulnerability or connected medical devices currently contain critical vulnerabilities. Cyber attacks once again have topped ECRI's top 10 list on health tech hazards. Hospitals, in many cases, don't even have decent inventories of what they even have connected to their networks. 80% of healthcare IoT devices get used monthly. The challenge with that is if you have to be continually patching these devices because of vulnerabilities that are coming on board, we're identifying these on a regular basis. Medical device manufacturers are expected as part of their regulatory obligations to be monitoring and patching vulnerabilities. There's frustrations though, because those medical device manufacturers who do push out those vulnerabilities, they can have a very low uptake level from hospitals because hospitals are trying to use those devices every day or every week. And it's really difficult to put those patches in place and then retest the system to make sure that all of those devices that are connected to it are all still working. Infusion pumps have been a really common item here for focus for both security as well as operational safety. Infusion pumps were a hot button item when I joined the medical device industry in 2010. They've been continued to be a focus area for security and other issues. 73%, according to, and there's a link to where these numbers came from in the bottom corner of this slide. 73% of infusion pumps on the market today have a vulnerability that could jeopardize patient safety or privacy if it's exploited. These numbers are massive, considering we've had guidance in place for 8 years now, finalized, and we've definitely been tackling this issue for well over that in our industry. The other issue here is the threat landscape and how threats have approached the healthcare infrastructure have changed. One example is ransomware. I probably don't have to explain WannaCry from 2017 to anyone on this call. However, the actual numbers for medical devices, it was not necessarily an attack directly for medical devices, but medical device and hospitals were affected greatly. 1,200 diagnostic devices were hit. 5 UK hospitals, ERs, were actually required to close because of this issue. And 83 of the 236 NHS hospitals were infected, with 19,000 appointments canceled. An interesting aspect of this, I did a case study on WannaCry a number of years ago, and one of the reasons that 83 of the 236 were affected and not all of them were affected is because there was a budget to update patching for all of those hospitals, and it ran out. And so the hospitals that were affected were actually as a result of a budget cut for patches that were already available. So that's why it was restricted the way it was. The FBI and DHS consider this a sponsor by North Korea, potentially in retaliation for economic sanctions. So hospitals are no longer just kind of a side impact. They're actually being attacked by organized, sophisticated, and skilled criminals. So we need to get better at protecting against these advancing attack vectors and threat actors. Currently, ransomware accounts for more than 70% of the successful cyber attacks on healthcare organizations for the past 2 years. So this is a huge number. And in order to protect against something like ransomware, we do have to have new approaches and more rigorous controls around how we manage medical device security. So enter the regulator, right? So with all of these numbers that I've just presented to you, my hope is that it is now clear for you why FDA is still working on advancing this guidance, and FDA are not the only ones. That's the icon I have here, but regulators across the globe. One of the things that keeps me very busy in my organization is what worked last year for, say, the EU or Australia is this year, it is not any longer meeting that bar. New expectations, new levels of detailed information that's expected. This is changing regularly as regulators learn more about what they want to ask for. And so if you look at a medical device that started in its development 5 years ago, which is the average development time for a medical device, the regulatory environment is changing during that development time period. So you actually have to be keeping up to speed pretty regularly to make sure that by the time your product is ready to go through a submission, that you're actually up to date on the regulatory expectations today. So what are those key expectations? As I said, we don't have the privilege of having a lot, several days to talk about this, or even several hours. So the key things that regulators want to see is that you understand and you act on your risks. Security risk management, threat modeling, we'll talk about that in just a moment. That you're designing devices with security in mind. It should not be an afterthought. It should not be a bolt-on. Kevin mentioned that a little bit in the preface to this talk. They also want to see that you're testing the resiliency of your devices, both theoretically with threat modeling as well as physically with pen testing. Nearly every area across the globe, every jurisdiction wants to see these things that you've put them in place. The details of exactly how you do that is a little bit different, but you still need to be approaching your your quality system with these expectations in mind. Managing your supply chain, having an SBOM. An SBOM is something where it's almost like an ingredients list for that pack of M&Ms that you got. If you're allergic to, say, nuts, you need to know whether it was produced in a factory even that produces things with nuts. The same thing with SBOMs or similar things with SBOM. If you have a particular library or a particular operating system with a known vulnerability and you haven't patched that, it's important for those who use your products to know. So having an SBOM so that you can track the status of new vulnerabilities within your own products, sharing that SBOM with those who are using your products so they can know what's in their purchased product. A big part that I see getting more attention, and I'm glad to see this, is the concept of the post-market space and putting a focus in this. A lot of times in medical device manufacturers, post-market is kind of a secondary thought. It's a passive approach, right? If we get complaints about something that's breaking on a device, we kind of look at our risk management file. Did we expect it at that rate? We did expect it at that rate. We're not going to really act. Is there something more frequent or more severe that we're seeing? Then we start to act on that. But we wait for someone to tell us in many cases, in most cases. With security, you have to proactively monitor for new vulnerabilities. You need to get in front of those threats and vulnerabilities so that you go and patch them before they become incidents. But every best laid plan, you may not get everything. So you do also have to plan for the inevitable and have an incident response process as well. And these are all things that regulators want to see. A big part of this, the FDA is particularly vocal about the need for a good communication plan with your customers, sharing that responsibility with those hospitals or those other users of your medical devices so they know what you know and they're notified. So if they need to do something while you work on a patch for a particularly critical vulnerability, that you have a way of communicating that. And that may be through release of an advisory in a public forum or on your website, or that may be direct communication to your customers to let them know that you've identified a new risk and that you're working to address it. So these are kind of big picture issues that we are looking to solve. There's also a centralized source of common principles and practices, which is the IMDRF document. Dr. Suzanne Schwartz was a co-chair for this particular document from the FDA. And this document is a really nice overlay of centralized common principles. Because medical device manufacturers are not necessarily held to this, the IMDRF is a forum where regulators are supposed to use this information to help develop their regulatory strategy and expectations. So while medical device manufacturers are not necessarily held to this, it is considered a nice common source for understanding what should be expected in a common medical device security program. And it's, in my opinion, it's very well written. It's a really great source of good, solid principles and practices. They talk about the overall product life cycle, talking about expectations around development, support, and end of support activities, which are all very important in planning for security issues. Another document I'd like to kind of mention, which I think has a really great framework in it and is a very good resource for understanding what goes into designing and maintaining a medical device from a security perspective, is the Joint Security Plan from HSCC. They are working for an update on this particular document, but they do have a nice framework here when you think about all the different things that have to go into a product security framework and how we manage security within the larger context of a quality system. So your basic aspects of concept, design, development, qualification, and launch, those are across all of your quality system. That's in the top of this figure. But within there, within the bounds of the design, control, and risk management activities that are happening throughout this process, you have the security specific elements in the lighter gray. So you have security risk assessment activities, you have design activities around security, understanding your vulnerability profile and what is potentially needing to be addressed within the components of your devices, verification and validation, pen testing, security testing, and then the post-market aspect of vulnerability management, patch management, incident management and response, and end of life. So all of these parts are not only important for you to manage security for your customers' benefits, but also from a perspective of what regulators are going to want to see as evidence that you've done this job and plan to continue to do it in the post-market space. There isn't necessarily a standardized list of those elements. There's the JSP and the IMDRF, and there's various regulatory guidances. However, I've put together kind of a 7 pillars of product security that I use to explain some of these issues, where you have your governance. How do you manage this program? How do you mature the program and continue to respond with new expectations? Design issues, testing issues, labeling and communication. What do you talk to about your device and how your device's security is implemented, and what your customers can expect from security? Sometimes this includes security white papers. Security risk management and threat modeling is a huge area within these pillars. Vulnerability management and incident response. Now, this is not every single element you would ever think of, but there's some big picture items that you should think about when you're thinking about working with your medical device, and also making sure that you're addressing all of these issues as you're developing it. So we're going to go over a couple of these aspects and just talk to you about why they're important and what they entail. So secure design is something that is absolutely critical for having a device that's manageable, both through a submission as well as in the post-market space. You cannot bolt on security. Whoever built this bathroom was definitely not thinking about the larger expectations of this sink to be installed. It's kind of how it's kind of the mental image I have when sometimes when I'm looking at the secure design aspects are kind of off to the side. They're not integrated into the larger development process. And so when things are not integrated to the overall entire design process and they're added more of as an afterthought when you're looking at risks and you're trying to close those risks instead of proactively looking at that, the execution is not nearly as effective as it would be if you included those secure design requirements throughout the process. And so those requirements really need to come from a variety of places. And if you don't think about developing good secure design requirements in advance as part of the implementation, then you're going to be missing proper execution of that secure design. Another aspect that I talk about from a testing perspective is that there's 2 different things that tell you whether you did a good job during that design. One is penetration testing, and one is threat modeling. And these are not the only things that you're using for testing, but sometimes I see people get a little confused about these 2 concepts. So I have a slide here to talk to you a little bit about, 1, why do the regulators want to see both of these things? And 2, how do they integrate into your compliance and your overall quality process? Penetration testing is often done later in development. So you actually have a device that someone can take and try to break. Penetration testing is having a good guy act like a bad guy and try to break into your device as best they can. Threat modeling is more theoretical, right? It's taking pen to paper and saying, how might a person break into this device and what can we do about it and what controls do we have in place? Threat modeling can be done earlier as you're conceiving of the design, and it can be a really good feed into secure design practices and identification of good requirements because you're thinking about that approach. The objectives of pen testing are actually to test the device's resilience once you have a device in hand. So you have to have something to test in order to do a penetration test. For threat modeling, you actually only need the design in many cases. And so if you're doing threat modeling early and often, as is recommended, it can actually help prevent design flaws rather than just surfacing those design flaws later in the process. Penetration testing generates a list of bug fixes or issues, right? So the design is at a certain level of development. So now pen test is probably going to surface some things you didn't think about. And then you go back to the drawing board and try to address those in iterative fashion. Threat modeling, if done early, can actually provide good design changes to consider prior to getting to that point where you're actually physically testing the device. Now, I make this bounce in because I want to just mention this is really just described conceptually. There are, of course, lots of different aspects of these 2 processes that are helpful, but I'm just trying to provide an understanding of how you use these 2 parts differently and how to think about them and why they're both important, and why regulators want to see them both, not one or the other. Along that same line, I want folks to think about the difference between design flaws and bugs. Design flaws are poor choices in how you created the system, how you design that system. Bugs more commonly are thought of as coding errors. A lot of times when we see a vulnerability, from something in our SBOM, something in our list of components, we're seeing some kind of coding error that we need to address. And so threat modeling won't identify coding errors, but it will help you find poor design choices. You still need other types of testing like penetration testing, vulnerability monitoring, verification and validation to find those kinds of coding errors, poor implementation, and other kinds of flaws. And again, this is why the FDA and other regulators are asking for a lot of evidence, because they want to see that you're thinking about security throughout the process, and they want to see that you're really thinking carefully about how you're designing these particular issues. Security risk management is a very important part of this as well. We've got TIR 57, which is a very well-known technical information report that is used, even though it's a US standard technical information report from AMI, it is actually referred to in nearly every single global regulatory guidance out there, even outside of the US, because it is considered so foundational. And one of the reasons that I know Kevin is because he was the co-chair of AMI TIR 57 on its first go round. So this is a really important part, specifying in principle that security risk management is a unique process that should be run in conjunction with your safety risk management process through 14971. There are some unique aspects to this. And so when you're putting in your security risk management documentation, you need to be thinking about some things that the regulators are also going to be looking for. Some unique things are, how do you identify security risks? What are you doing to identify those risks? A lot of times for safety risk management, we look at historical data or we look at life testing. But for security risk management, you have a lot of different types of sources. Also, how you're scoring to accept those risks. When we look at 14971 for safety risk management, you look at probability, and this is often mathematical probability of something happening based on life testing, how often a part breaks, and severity of occurrence, often safety related. For security risk management, it's a very different aspect. And we're looking at the likelihood of something that might happen. How attractive is the target? How hard is it to exploit? Those kinds of things. And then what kind of impact it might have. And then all of those scores also have to link back to safety, because you look at it from a security perspective, as you've seen in that previous slide here. You're looking at risks from a security perspective, and if they have a potential safety issue, you port them over and duplicate or propagate them over into the safety risk management. So there's two layers of assessment. You have a safety risk assessment layer and a security, because you can have an unacceptable risk for a medical device, like a pivot point into a hospital, even though that may not be an actual safety related risk that you might respond to in 14971. So we talked a little bit about sources of those risks. When you're starting to put together your documentation for your security risk assessment, you should be thinking of a number of different sources for where you're getting those risks. Your threat model, we've already talked about a little bit, that theoretical analysis. There's also the pen test, which we've also talked about, an actual cyber attack simulation where a tester attacks a real device. But there's also vulnerability analysis, analyzing your SBOM. Are there any vulnerabilities associated with the components? And then lastly, historical data. You may have similar products or versions or other products within the industry that are having issues that you want to be aware of as part of your threat intelligence. We talked about this already a little bit, but threat modeling is kind of new to this industry. So I talk about it a little bit more in this particular presentation, because threat modeling is, I'm a security risk management expert by training and by background. As I mentioned, I work quite a bit with Kevin on TIR 57. I've worked in this space for a while. Threat modeling is a very important feed into that process, because it helps you understand potential causes of harm. And in order for threat modeling to do well, it has to be a structured activity for identifying and how you've potentially controlled those threats. I really like this OWASP quote that talks about threat modeling looks at a system from a potential attacker's perspective, as opposed to a defender's viewpoint. A lot of times when we're looking at risk management activities, we're looking at what we want to prevent happening and what we want to defend against, what we want to control, what types of risks we want to control. But threat modeling actually turns that around and says, if I wanted to attack a system, how would I do that? And that's how you understand what you actually need to defend in a way that's theoretical, but also can be done much earlier in the process and throughout. A little bit more about threat modeling. Again, it's a fairly common topic right now. It's a hot button issue. People are struggling a little bit with this, and it's important. But it's important to regulators for a couple of reasons. As we mentioned, it's a very important way of delivering information to the design lifecycle to help ensure that you've had a complete consideration of all the secure design you need to work in, and that all those requirements are in place. It's also essential for security risk management, as we mentioned. Risk management is an absolute requirement for any submission across the globe, and security risk management is an important sub part of that that needs special attention. It also is really important. Threat models help us understand the types of abuse cases and kind of testing that we want to see. Threat models are considered expected as part of security risk management by FDA right now. And they use the threat model to really understand your system and how you've thought about securing your system. I consider them one of the more important parts to get right for a submission, particularly with FDA, because they are, in my opinion, one of the best ways to describe your system and how you've handled it in a way that has figures, diagrams, and explanations that can really help convey what you've done and what you've thought about. Uniquely compared to a spreadsheet from your risk management file or other things that are a little harder to grasp and capture the big picture. The last thing I wanted to kind of talk about are the things that regulators are looking for is the post-market space. This is an area that I think still needs a lot of maturity overall across the industry. Because there's different things in post-market for security than we see in other post-market space activities. It's much more proactive. You have to be on the lookout for new vulnerabilities, vulnerability monitoring of your SBOM, threat intelligence activities with ISAOs and other sources of information. Once you find those new vulnerabilities, you have to decide whether they're actually affecting your product. And this is part of post-market risk management for security. They may not be exploitable the way you're using that component, but you still need to analyze and document that. Another issue here is it a big deal? And the way I describe this is you may have a vulnerability that could be found in your device by scanning it, like a hospital may scan it and find a vulnerability. You may have determined that it's not exploitable to your device, but it may be one of those big named vulnerabilities that everyone's hearing about, say WannaCry, Petya, not Petya. For whatever it is for your product, it may not be vulnerable, but if it is being considered as a large global threat, these are extra considerations you might want to make and how you're telling your customer and whether you fix it or not. Another concept, and this is a US specific concept, is whether it's controlled or uncontrolled. An uncontrolled risk just means that there could, if exploited, be unacceptable safety implications of that particular vulnerability. And if it is uncontrolled, you need to communicate with your customers within 30 days, and you also need to patch it, preferably within 60 days. The next part is actually preparing that patch. And this is another area where we see a lot of compliance challenges because you may have devices that in the past have only undergone software updates every few years, but when you're looking for new vulnerabilities, that patching rate could increase exponentially, and you may be patching every month or more because of new vulnerabilities that you've identified that are considered unacceptable. Having the resources and a plan for how you're going to be releasing those patches and how your device can be patched and how you're going to notify your customers of those activities, all of these things can create massive drain on your resources and your planning if you don't carefully think about this in advance. This is also why you're seeing more and more regulators saying, I want to know what your post-market plan is. Because if you've not thought about this and you are allowed to go to market with your product, trying to figure out all of these things after your product is on the market is not really a reasonable expectation. So those kinds of things are being asked for at an increasing frequency in a lot of regulatory submissions. What I will say, though, is that when you look at the actual guidances and the specifics, with the exception of probably the US, which has a very detailed post-market security guidance, the expectations are fairly high level. Have a vulnerability management plan, have an incident response plan, have post-market security, but they don't really specify how they want it done, which in some cases can be kind of difficult. So using the US as kind of a flagship guidepost can be helpful because the FDA has outlined post-market security expectations fairly distinct and in detail. Vulnerability management, these two particular standards are recognized by the FDA and they're used pretty heavily across, and they're connected. So you have vulnerability handling and vulnerability disclosure activities. So the vulnerability management process should be identifying your SBOM and all particular sources of vulnerabilities, then monitoring those sources, not only vulnerabilities within your product, but also threat intelligence activities about what are the emerging threats. Kevin talked a little bit about those in the beginning here today. Then you have to determine, is it exploitable? How bad is it? Is it controlled? Can you control it with compensating controls, which are controls that your customer puts in place when you don't have a design solution yet, or if it's not possible. Disconnecting a product from the network is one way of having a compensating control, although not a very popular one. Change management, V&V software release. How are you going to actually implement these changes and then get them out to your customers? And then the actual process of, so basically what I'm doing is putting it into medical device speak on the right side for the items that are kind of generically outlined in the process from the standard. Lastly, we have incident response. Incident response is planning for the inevitable problem that actually gets through your network of controls. And so there's lots of sources for general incident response. The thing that I will mention is if you're a large organization or you're part of a large organization, usually your enterprise, your overall company structure will have an incident response plan for their own infrastructure. You'll often need to kind of collaborate and coordinate that, as well as other stakeholders. If you do have an incident and you haven't notified your central leadership so that they can manage it in a public disclosure aspect, and legal and corporate heads, there's a lot of chain of command activities, as well as somebody needs to be in charge. It can't be groupthink. It can't be group decisions. You have to have a person in charge, and they should have experienced some tabletop exercises to test out their process and how that process will flow with unexpected information as it comes through. Last couple of items here is the challenges. This is just to kind of close out, like, we have all these expectations, so why aren't we just handling this? Why is it taking this long to address these issues? And there's a few reasons. One is for any given hospital bed, there are 10 to 15 medical devices for each of those beds, and many of those are connected. Any one soft spot in any one of those devices puts that patient at risk. So every vendor has to be on board. Every one of those medical devices needs to be patched, and it needs to be under support. But medical devices are continuing to age, right? And so we have these medical devices that in some cases are built on very old operating systems that are out of support, and they can't be patched. So what are we going to do with all of these devices that are out in the market, and we actually can't patch them? There is no possibility of patching them for certain components. And so the solution means, well, why can't we just patch? Well, it becomes more difficult. A lot of these devices were not designed to be patched remotely. And so having medical device manufacturers go out and touch every single device every time they have a patch is logistically very challenging. And even getting those patches for some of those components is very difficult. Even if you can patch them or you can design new devices, there's still the money issue, right? Medical devices are creating more resilient devices than they ever have, but those old devices, quote unquote, still work. So the hospitals are still using them. They don't want to replace something that still works, and they don't have the funding to completely overhaul their medical device inventory every year as new medical devices are released that have better, stronger medical device. So hospitals are under greater pressure, even more so now after COVID, and these medical devices are just going to stay on the market for a little while longer as we continue to try to tackle these issues. In my closing statement, I will just kind of remind folks, I know there's a couple of questions here in the Q&A. We'll get to those right now. Cybersecurity is something that requires all of the stakeholders to work together to find a successful path forward. And so it's a very important thing to not only tackle within your own space, but also, you know, as many of the manufacturers and individuals, myself included, have been participating in these multifunctional groups along with regulators, where hospitals, manufacturers, regulators all get together to try to solve some of the more challenging issues. SBOM would be one example of those. So with that, I'm going to transition to Q&A, and looks like, Kevin, you'd like to answer one of these questions. I'd like to go ahead and please pass that over to you if you'd like to take that one as the first one. Please go ahead.
Thanks, Michelle. I was going to say, actually, one of the attendees has a question for you about international aspects, and I thought you might be able to talk about just a little more globally from the medical device manufacturer's perspective of cybersecurity risk management, pre and post market. Maybe maybe you could get more into IMDRF or just interesting things you know about beyond the U.S. borders.
Sure. Yeah, and that's one of the reasons that I pointed to the IMDRF itself, as you pointed out. I have gone through every single guidance out there, and point by point, requirement by requirement, and fortunately for us, they tend to be fairly similar. I would say that some of the areas of commonality is security risk management, and the approach defined by TIR 57 is nearly universal. Security risk management, secure design aspects. Each regulatory environment has some different, what they would consider recommendations to consider for good secure design or controls. But most of them don't include hard and fast rules about particular areas of design, but they want to see that you've thought of it. And so if we go back to this list, oops, let me get screen, there we go. If we go back to this particular list here, sorry, I should have gone over, that I had kind of in the beginning of this section, sorry, I should have gone through there. Pretty much everything listed on here is generally expected across the board from regulators in nearly every jurisdiction. Some of them are more specific than others. One thing that I would point out, that threat modeling is currently only called out by the US FDA, specifically asked for. But what we are seeing, for example, in Europe, I just did a presentation with TÜV Süd, and they were saying that they are actually asking for threat models now, specifically with STRIDE applications. And so that's very interesting, because their guidance, the MDCG guidance from 2019 for overall aligning cybersecurity expectations, does not say anything about threat modeling. It talks about security risk management. So I suspect we're going to be seeing more discussions around threat modeling and threat modeling expectations as part of security risk management, especially since it's identified in IMDRF as an expectation. And so those kinds of things going in the pre-market space are big parts of that expectation. Supply chain. Another thing that the EU and Australia put a lot of focus on is around the operating environment and how do you communicate that. So there's a lot of expectations in these different areas about making sure that you communicate what the hospital or the user needs to know about the security of your device. Post-market expectations are fairly generic, except for the US, but they all want to see that you've got some kind of vulnerability management process in place, some kind of incident response in most cases. They don't always mention incident response. A lot of times they'll say something as simple as you need to have post-market expectations and have like 3 bullets. And that's about as much as they talk about. But places like the FDA they're actually wanting to see evidence that you stood it up.
So Michelle, I've got one question as well, and I see we have a number of questions coming up in the queue. I'm curious if you can share any stories. I know you work with a lot of MDMs, but have 510Ks, PMAs been returned when they didn't have an appropriate cybersecurity case? What are you hearing?
Yeah, this has been so a lot of times we talk about the FDA in this kind of perspective. And so one thing that keeps us very busy is there's been an initiative, the Focal Point program at FDA, where there are common types of expectations that are run across all of the branches. So you see common questions being asked of medical device manufacturers when they go through a submission. And those questions are changing quite a bit. I have seen a lot of questions come back. I think from my perspective, and we usually get called in when people do get questions, unless people are very, very careful and are usually using a consultant in the space, they get some kind of questions from regulators about cyber. And that is not just in the US. We're seeing that from notified bodies in the EU a lot more than we had seen it in years past. And they're asking very specific questions about how you've enabled security and address security in your devices, very similar to the FDA.
Well, I see we have a lot of questions in the queue. Maybe there's some in there that you feel like we can get to. We have about 5 minutes remaining for the questions.
Let's see. There've been quite a few more that have come in since. And I have no problem answering these offline too, if I can get the list of questions. Kevin, I don't know if there's a way of sending these things over to me and I can answer some of them offline, but there's a couple of these that I can answer fairly quickly, which is a separate security risk management process or combined with safety risk management. One thing that the FDA new guidance does very specifically outline, and nearly every other guidance except for Australia, they only really mention 14971. The separation of cybersecurity risk management from safety risk management has been established as a fairly well-established expectation. You won't get in trouble with Australia if you separate them, but Australia doesn't really specify so much that it has to be. But the EU, the US, Canada, many of the other jurisdictions are talking about this separation, and the most recent pre-market guidance from the FDA specifies that you cannot do proper security risk management without addressing it with relation to some of those items that I mentioned today around scoring and where you're getting the risks from and how you're analyzing them. So hopefully that answers that question. There's another one here on the reasonable documentation to provide for a submission, read the risk management file. Typically one includes their risk assessment and control measures. What would a security risk document look like? One good thing that's coming up is I just got notification, AMI, which is the standards development organization that put out TIR 57, which is really the seminal work in this space across the globe for security risk management. They're about to release what is called SW 96, which is a full standard on security risk management. And it actually goes into a lot more on the risk documentation and what it should look like, including just like you should have a risk management plan for 14971 and a risk management report and assessment, usually in the table format. All of those things that would be part of a 14971 security risk management file are equally expected with security risk management. With the addition that you should also have threat modeling information in there so that you have good basis for where you're getting those risks that you're assessing in security risk management. I do not suggest that you combine security risks and safety risks. However, you do need to analyze every security risk, whether it has the potential for safety, and then propagate it and add that risk, not replace it, don't move it, but also assess it with your safety risk management process. Another question here is around threat modeling figures and diagrams. When I think that, Kevin, you may have had the MITRE threat modeling playbook up there. The MITRE threat modeling playbook has a nice outline of things like data flow diagrams and other expectations around figures and diagrams. When I'm talking about diagrams in a threat model, I'm actually talking about a good data flow diagram where you have all your components, the data that's flowing, the interfaces, all of those aspects to understand how your system operates, what it's connected to. You do have to include things that are peripherally connected to your device, even if they're not part of your system itself. FDA does not have a preferred method. They're open to any method. I will say that it's probably easier to use, at least as a foundation, something like STRIDE, because it's well known and it's a methodology you can point to. TUV Sud, when I presented with them, they did state that they preferred STRIDE, which was unusual because they don't really state out there in their expectations and the guidance that they expect threat models at all. So,
yeah, and that threat modeling book is really easy to find. Just Google MITRE playbook medical device threat modeling. It should be the first or second link.
Yep. I know that we're kind of right up at the ending point. Can I just take 30 seconds to answer?
Yeah, I was just about to ask if you have any closing thoughts, Michelle.
Yeah, so there's one more question in here, and I'm sorry I didn't get to them all. Anyone, my email is at the end of this. If we didn't answer your question, you feel free to ping me separately, and I'll answer it for you via email. If we can't do like a joint thing. The difference between bona fide security risk management or infrastructure and turn the crank, check the box approach, all that, in my opinion, comes when you're starting to demonstrate evidence from your threat model and your risk management documentation, which I think is why they're so critical to any submission. You can list all kinds of things that you thought about or that you supposedly have a plan for without even putting the plan in your submission. However, you cannot fake a threat model, and it's very hard to fake good security risk management. They're very good places to sniff out the real versus the check the box type of approach. So I don't know if you have anything to add to that, Kevin, but when I think about how do you really show somebody knows security, is you look at their threat model and security risk management.
Yeah, I mean, my own opinion is a good threat model is refutable. So if it's simply a statement that's not refutable, that's not a very strong threat model. Yes. But if it's something that can be refuted with data, if it turned out to be false, that would be a reasonable threat model, in my opinion.
Sure, thank you.
All right. Well, Michelle, did you have further closing thoughts?
No, I just said thank you.
Okay. Thank you so much for taking time out of your day and being our final speaker of the year. Again, Michelle Jump, CEO of MedSec, and we return in 2023 on January 19th with John Ridgey from the American Hospital Association, who will be talking once again on medical device security from a healthcare delivery organization standpoint. So happy holidays, and we'll see you in 2023.
Sounds great. Thanks, everyone, and thanks for your attention.